I've heard about this thing for weeks, months, years. I even contacted the Instagram in 2023 when I heard the first about this. And I am right now in the Perenthians Islands at Anti-Gravity Divers to try the new system called Avelo that promised to revolutionize the entire diving industry without BCD. How does this work? What is that thing? How does it dive? Everything is going to be answered in that video. Hi everybody, my name is Maxime and I'm a professional underwater photographer and cinematographer. And today I'm in the Perenthians Islands in Malaysia to try the new Avelo system at Anti-Gravity Divers. So let's go and get right into it. Avelo actually promised to have one of those effortless buoyancy system, something crazy, like there is no BCD. We've always been diving with BCD, and they are replacing that with a new kind of pressure vessel. They call that pressure vessel because it's not only a tank, but it has different components. And that's pretty much what I understand of it. So I'm gonna be going and give it the full course. And also I've met here the amazing inventor of the system, Aviad, that is gonna give us a bit of a tour of the system, explain to us what it is, what it isn't, and then we're going to go diving, obviously, because if we're not diving, then it's so exciting.
Before we go further, I will be having a full interview with Aviad, the inventor and owner of the company Avelo, at the end. This is a long interview, so if you want to switch to it, this is the timestamp. If not, this is going to be directly my review. At the very beginning, I thought it was kind of odd. It's very, very light. As soon as you get underwater, it's where all of the magic happened. It is extremely easy to find neutral buoyancy because we start the dive pretty much neutrally buoyant already. And because of this, as soon as obviously the gas get used and there is less weight in the tank, adding a little bit of water just makes us remain neutral. If I could give you a comparison, a photography comparison, it would be like when you turn on stabilization on your camera. It is very weird because your breath and the way you breathe, regardless of the position or your trim, actually have much less of an impact that you would have with a BCD. Remember guys, this is coming from somebody that has thousands and thousands of dive on BCD. The difference is even greater when you give that kind of tool to an open water diver. In here, you can see my dive buddy next to me is an open water diver, and she has probably, I think, 13 dives. But regardless of this, she was moving in the water column effortlessly, had minimal buoyancy problems. Something that at this level, even when taught correctly, you wouldn't see. Is this really the future of diving? I think it might be, yeah. I think we are finally innovating for the first time in 40 years. And there is a company that decided to go this way, and I think we should just all try this and see how amazing it is. The innovation that is being brought up by the company is amazing, and if you get the opportunity to try it, just go for it, because this is great. I know that if I get the opportunity to choose with a standard single cylinder tank and an Avelo system, I will definitely go with the Avelo system. Now that we're done with this, let's go with the amazing interview of Aviad. I hope you liked this part of the video already, and I asked many questions to Aviad, and he's going to answer them. So
first, thank you very much for accepting to do this interview with me.
Oh, thank you for hosting.
Yeah, I'm very happy. So can you please present yourself to our amazing audience and talk a bit about yourself?
Hello, everybody. Thank you for watching. My name is Aviad Cahana. I'm the CEO of Avelo.
Good.
You want background?
Sure, go ahead.
I'm a chemical and environmental engineer in my background, and a scuba instructor from the Red Sea. Worked in it for a while, got out of the industry, got back into the industry, and now teaching Avelo with my team all over the world.
So you invented this.
I did.
Where did the idea come from?
There's a dive site in Hawaii, in Maui, called Mala Wharf, which is a beautiful dive site. But it's a long walk, and it's a hard walk.
Okay.
And on the way to the water, I had the thought of, why are we carrying gear so heavy for so long, and why did it not change? And the thought was, first of all, it's a dangerous walk in because you can't really see where you're stepping sometimes, and it's wavy and it's rocky and all that. I was like, well, you can't really change that because we have to. Yeah, there's a certain amount of mass in the tank that on top of it you have to take weight because you're going to breathe the mass out. And like 5-10 minutes into the dive, I'm like, wait, if you had a lightweight tank that you every time that you breathe out from it and you become a little lighter, you can make the tank shorter. Just so you won't have that much displacement. And if you magically can do that, then you don't need to carry weight at all. In fact, in that case, you can actually just go into the water, let the lightweight tank float you, and then when you're ready to go, you just magically make it shorter, and then you dive for 10 minutes, you make it shorter again and shorter until at the end of the dive, when you want to float again, you make it go back to its regular shape. And I'm diving, so I'm also looking at stuff, and I'm thinking, well, that's they're like, wait, piston accumulators. A piston can do that. And I'm thinking, so the dive became a dive of like thinking, and then I'm like, oh, an accumulator is a device that can do that, but it's not made for this purpose, but it can do the same thing. So the purpose was to make a tank that becomes smaller throughout the dive, only for weight purposes. The idea was to make something lightweight. By the end of the dive, it was like, oh, carbon fiber. Carbon fiber would work, and a bladder inside the tank would work. Now I need to go do the math. Half of the physics calculations were done in the shower, right after the dive, in the outdoor shower. The rest of it really needed an Excel sheet.
So great. So that's one big product of an engineer's mind, right? Like thinking during the dive, thinking about it afterwards. What was the early days like? So when was that? It's like 2022, 23, something like this?
Oh, that was early. That was more 2017.
Oh, okay.
Yeah. And it was just an idea.
Uh-huh.
But I also come from startup companies, so I knew that it's going to take some time. And it was just an idea. In the early day, the idea was different. Don't use electricity. In order to pump water in, use a regulator. Right now, you're wasting a lot of energy on the regulator. At the time, the idea was you only need to displace 1 gram of mass from what you're breathing with 1 gram of water. If you do that, you will always be neutral. And at the time, we didn't know that wetsuit compression is not what we think. Like, as a team, we had no idea. So the early days were go find somebody that will allow you to use a tank like that for underwater and make a regulator that every time that you breathe, the regulator itself will be different. It will work like a pneumatic pump. So the energy from the air, from the compressed air, will actually drive the regulator. So every time you take a breath, the pump pumps 1 gram of water into the tank. That was done in 2018. And if you are, for dive instructors, which the whole team is, our level of buoyancy was very good. So for somebody like that, you can go into the water neutral, and it's a mechanical, automatic, neutral buoyancy control. And it really is magical. It really does leave you the whole dive. But you don't have any buoyancy adjustments. Like if you need to purge water out, now it can't compensate for that. Like it can't. So, but it was great, and it doesn't require electricity. That was the early days. In 2019, we shifted to electric. And again, it was a hobby. It was just, let's see if this would work. The dive quality itself was unbelievable. Like we knew then that this is going to replace BCDs. Because now that you know, the quality of the dive is the real measure. But because we shifted to electronics, we had all the time to go figure out why, when you go to say 30 meters of water, even with heavy wetsuit, even with 7 millimeters, we're not seeing the buoyancy changes that you expect to have. Because in your mind, you're going with a 7 millimeter suit and you're going to go deep, you will need a BCD. And the truth is that you don't. That's how we discovered that. Because we were diving with a device that wasn't quite ready, but with all kinds of wetsuits from all manufacturers, small, large, shorty, you name a manufacturer, we dive with their wetsuit. So that's where the first early years. In 2019, we got the first prototype that worked consistently, and then COVID hit.
Obviously.
Yeah.
So during COVID, did you have any development, or did you just dive the tool and then? I guess it was still in your, like as you said, a hobby.
Yeah.
When did this shift to become a company?
By the end of 2020, with all the COVID shutdown and slowdown, we have very good people that work for us that can do a lot of things in terms of manufacturing and prototyping and rapid prototyping. At that point, because we're all dive instructors and we did other things in life too, we knew that it's worth making a company because the dive experience, the safety, the lightweight, the dive experience, all of these together can change scuba. So in 2021, we participated at DEMA. We knew that the device is not ready for mass production because we wanted to hone the certification, the training, all the things that come out of it, the computer side of things that just collects the data, doesn't control the system. So in 2021, we knew that this is going to be a real thing. But we also told the world at DEMA, we're still not ready for 3-4 years. Like there will be things in development that we'll still do. And once we go commercial, it will come with all the things that you're seeing now because they're ready.
If I remember well at the beginning, I think it was rental only kind of model, and now you are more into the retail. Like, what did make you shift towards one to another?
The only time that it was only for rental was still in sort of a soft pilot, soft launch, where you're saying, we need to see what the gear is doing. And when under a rental agreement, it's easier to talk to the customer, talk to the customer's customer, because our customer is the dive shop. So it's a lot easier to make sure that the experience is good, that the training is consistent, when you have all the control of the gear. When we, at some point as a company, we decided that it's ready to go and be in the hands of people that will travel with it to locations that you don't know, with no support, with no technical support. And we're very methodical as a company. We release things after we put them in the field. We make sure that we know what happens. We see the good and the bad, and then we release.
So let's talk about the concept itself.
Well, that's a 3D printed.
Yeah.
Part.
I'm gonna take a real one.
That's the real deal.
Let me take a real one.
That's an 8-liter real deal.
It's an 8-liter real deal.
Yeah.
It's beautiful actually, the wrapping on this one.
Yeah. That's Jennifer Idol. Kudos to her.
Fancy one.
Yes.
Okay, so this is a hydro tank. Hydro tank. Hydro tank. Can you explain a little bit the difference between a standard scuba and the hydro tank?
Okay, so a standard scuba pressure vessel, which this is what a tank is the fixed inner volume pressure vessel. Remember how I said this? I explained the story of how this was born. With a standard scuba tank, the volume of it is fixed. The displacement is fixed. When you dive, you consume mass out of it, so it only changes one parameter. This is a variable volume pressure vessel because you change the inner volume by injecting water into it. From the physics standpoint, those are the changes. In a simple way to explain it is this is a tank inside of a shell. The air goes in the bladder. It's a high pressure air, 200 bar or 300 bar. And when you do that, the bladder just expands and takes the entire inner volume of the vessel. At the beginning of the dive, it behaves like any other tank. Then, when you're ready to go, you can control the inner volume of this by pumping water in. Water will go from a port, from the bottom of the tank. A little bit of water will go to the bottom of it. The rest of it will go around the bladder and will compress it. Unlike standard scuba tank, where when you control it with a BCD, you have large buoyancy changes. With this, you don't need large buoyancy changes. When you pump water in, it's about 1 liter, and that's all you need. That's all you need to take your head from above water to below water. From that point, your buoyancy is fixed inside the tank. Not because the tank does anything automatic. As you can see, it's a simple bladder inside a shell. That does nothing. It just doesn't change. Then you go and you dive. And as we said before, you consume mass throughout the dive. And as you felt, it takes you 20, 25, 30 minutes before you feel anything. And the only thing that happens is mass is reduced, but the bladder stays at exactly the same volume, regardless of depth, regardless of anything. When enough mass is consumed that you can feel it, and it's really subtle, as you know. Like the feeling is really, really subtle. You kind of need to look for it. When that happens, you run the pump and you put more water in the tank, and again, even then it's about a liter. So it compresses a little bit more. And now you have another 30 minutes of a dive, uninterrupted. At the end of the dive, when you're ready to surface, you get to the boat, you get your head above water, you open the purge, the bladder itself, because it's high pressure, it will push all the water out. And again, you're buoyant. And by the way, even if you didn't have any air in the bladder, it will still push all the water out because of how it's built. That's it. At that point, you're buoyant and you get out of the water. So it's the same idea. You have a tank that's with a variable volume inside of a shell. The rest of the system is just a pump that will pump water into it, and it's powered by a battery.
Can I show that?
So this is the jetpack. The jetpack is a harness, and on the other side you have a pump. That's the pump that will pump water into the tank. Again, once on the surface, maybe once in the middle of the dive. This is the purge valve. That's how you release it. Release the water when you want to. And we have a battery that is not shown here that will go in here. Now, the system, the pump, all of these devices, they are there to make the dive more pleasurable, but they don't cause any like major buoyancy changes. In a nutshell, that's the system.
I mean, to be honest with you, it's been very interesting for me to try it. I went diving even this morning with it. And yesterday I was diving my BCD, as you know. And like, it's just this feeling of constantly being able to tread water without any effort has been, I've been thinking about it for a while. And, you know, at the beginning, I came with it and I was like, okay, that sounds like a very good tool for beginners, because you don't have to explain to them BCD work, which is nobody floating up to the surface like crazy, nobody down. Like, it's making it easier for a dive instructor. But I see personally my own experience that as a professional doing imagery in the water, this has been great for me. Like, I can just stay extremely steady. If I would actually put this in words, it would be putting the stabilization on the camera. It's like it removes all of those micro jitter, all of those teeny tiny amount of up and down, and it's been very great actually.
Yeah.
So thank you to bringing that.
You're welcome. I would say to say that it's for beginners it's like saying that the BCD is for beginners. Because a lot of professionals will tell you that they don't actually use the BCD throughout the dive. Remember that conversation yesterday?
Yeah, we had this conversation together.
So the misconception before you go through the e-learning, I would say I'm a big proponent of physics. It's in my background. It's in my professional background. And you read our e-learning material and you see that it's actually pretty heavy in the physics for recreational diving. And the reason for that is that you still need to explain the fundamentals of scuba because it's important. It just, the tool that you use so far required a different explanation. And truly, the BCD is an experiential thing. You need to really hone it by doing a lot of dives, figuring out where your breath is. A lot of people believe that they understand the BCD, but as we know, it takes a lot of practice to truly hone the BCD against all the things that can happen with it underwater. To truly know and react quickly takes a long time. This is just a different tool. It works differently. It's a very different dive sensation, and it doesn't get you there. So, as you said, for recreational divers, there's an advantage, but it's funny how much an advantage this is for professionals, for photographers, for people that work underwater. And even for those of us, a lot of us are professionals who travel all the time and do like long, fun dives. Just to have more fun underwater, it's there too.
That is a very big point. Actually, I was talking to Ross yesterday about this, which was teaching here. It's like this has been the much fun I had on a single tank dive in, I think, at least 3 to 4 years. I was like, okay, now I can just look at fish and then just enjoy it. It's been a lot of fun. It's very easy, very practical. So yeah, it's been great. Honestly, it's been very, very great.
Thank you. When you asked me before how we knew that this is going to be a company, so all of us are diving this, and just imagine this like all duct tape and zip ties, and things are half working, and things fail all the time. They fail underwater. Yet the diving experience on a failed Avelo system was always tremendously better than every time that one of us needed to play like a safety person. Sometimes it was me. Feel like, why am I doing this?
Yeah.
Why do I need to go back to standard? So at some point when you teach so many instructors and so many divers, this is all pilots. The world doesn't even know that it exists. When you have a sample set of say 100 divers and every one of them comes out of the water and like the gears are thinking and they're like, I don't want to dive something else, you know that you have something.
And that's how you knew that you had a company.
Yeah.
Great idea. You started a very great partnership with Shearwater.
Yes.
And have Shearwater's computers have the Avelo mode,
Right.
where it's a bit of a shift, like, from my experience, a bit of a shift compared to the pressure, because obviously you have a pump here, so the pressure is variable,
Right.
and you have a percentage of remaining gas. Like I experienced it today, I was having only with the remaining gas, just looking at it. It's very the percentage, right? Yeah. It's very interesting because I was like, I still have 70 bar, but it says 20%, or maybe let's look into when the bladder is off, like when I'm fully empty, and then just how much, and it was exactly 50 bar. It's just I was like, the math in there is actually very crazy. But one of the parts that are even more crazy with the Avelo mode is all of this dashboard and all of this data. Can you just speak a little bit about this amazing amount of data analytics you can do?
Yeah, so in the past, BCDs, there was always a portion of the scuba industry that perceived the Holy Grail to be an automatic buoyancy control device. And the challenge was you never know exactly how much air is in the BCD and what the diver is doing, because tracking small air changes inside a device like that is very difficult. While we are not automatic, it's very easy to track the mass consumed, because you know that from the pressure, and the water in the tank, because you also know that from the pressure, as long as you use tools like the ideal gas law and some deviation, when it matters, there's something called the Z factor, so you use that also, where there's in high pressure you have deviation from ideal gas law. As long as you take those into account, and then you calibrate the model with real people in real diving conditions, you can get very, very accurate measurements of exactly the diver's buoyancy underwater. And then all that remains is to compare by the gram, compare how close they are to perfect neutral buoyancy. And now that you dove it, you know that when I'm saying perfect neutral buoyancy, this is not achievable with a BCD. This is truly precise. So once you measure that against their what we call workload and it's measured in liters per minute, and it's corrected to the surface. So we call it workload because it truly represents workload, and you also do it in a time increment that's relevant to their effort. We don't average it through the whole dive, because for us that doesn't matter. We want to see how they respond to different stresses underwater, and that's how you learn about yourself, how to be a more efficient diver. So the Avelo mode has two functions. The post, it records everything that you're doing. The post-dive data analysis, as you've seen, you're a very experienced professional. Your buoyancy control is absolutely fantastic on a BC. And even for you to see how you breathe after the dive has advantages. The other thing that is a result of that, because we do all the calculation, we know how much volume of air you actually have in the tank for real. Pressure is a poor measurement of how much air you have because of all kinds of things that are happening with the gas, temperature and others. We take all of these into account, and that's why we decided to just forget the pressure. As long as you have enough air to start the dive, which we define as 200 bar or above, we represent that as pressure. which for everybody, even though you reported pressure to yourself and to other your whole life in bar or PSI, still the percentage is like a much better tool and much simpler tool to communicate with others and yourself about how much air you have, because you know that everything is taken into account. So instead of using a proxy, which again, pressure is a okay proxy to know how much air you have, percentage though is perfect. The collaboration with Shearwater started with them incorporating in our algorithms to calculate the percentage, and very quickly transition into let's do post-dive data analysis, show it to professionals, show it to recreational divers, because the data is so good and telling that everybody has something to glean from that.
I get a lot of insight on it. Like really, I had different expectation of like in terms of workload, and yeah, I mean this graph with the tidal volume is great. I will show you guys on the video like the whole graph. It's like I didn't realize you could get so much data out of computer transmitter. Like that is a very great thing.
Yeah, the goal is to give the industry a tool going forward. It's a ruler. It's a ruler. What people will do with a ruler is what they will do with a ruler. But to develop the ruler was a lot of fun, and I think that it's very impactful because there will be people will do things with it that I can't even envision right now, and I'm totally okay with that.
That's cool. That's really cool. We scuba industry, we love to speak especially about failure and stuff like this. Like we love this. And I remember when we spoke with each other, you said at some part of the at the beginning, the purge, you had some issues with it on the, I think it was a drop of water that were connecting or not connecting the purge. Like, are you still refining this, or are you still finding any of those failure nowadays, or is it?
The failures were much bigger than you think. Batteries would not work. The pump itself would not pump. Of course, when you develop something, you have all kinds of failures and failures that you can't imagine. By the way, sometimes it wasn't even inside the system. It was the regulators or the valve that will fail, just like standard scuba fail. The conclusion from all of this was that failure modes on Avelo are safer. I'd rather dive a failed Avelo system than a working BCD. And now you know that because you have actually gone through all the failures because it's part of the training, and you did them. You did them fully. You know, you actually practice every failure that this system can have. We had you do that because we learned over time that you need to demonstrate to people that even if the system fail, they are safe. Failures in the system really have three things that they fall into those categories. For example, the battery doesn't work. For whatever, it really even doesn't matter. The electronic system doesn't work, the battery itself doesn't work, you didn't charge the battery, you didn't connect the battery. Or you inserted it backwards, like some would do.
You didn't dive with a battery like this.
Or you didn't dive with a battery, yes. So so whatever that is, it just means that you cannot run the pump. Now, with the BCD, that's scary because you think that the BCD won't work. But with Avelo, now that you know, the battery just allows you to set a point. From that point, you can control with your lungs so easily the rest of the dive that now you know, even if the battery failed, you have 30, 40 minutes to slowly ascend. It has no effect on your buoyancy. The battery in the Avelo system is for convenience, not for safety. It makes your dive more convenient. The same goes for the purge, right? We took you intentionally towards the end of the dive and said, if you have a water leak, to mimic a water leak, again, it's scary to a professional because they compare it to a BCD inflating without control. Well, a BCD will generate 15 kilograms of force. As you saw, because you've done it, with you could purge all the water out of the system, all of it. And you were neutral, maybe...
Tiny bit positive.
Yeah, maybe a kilogram positive with that. So failure modes on Avelo are safer than a working BCD because you can, on a BCD, when it's working, you can overshoot. So a lot of this is just explaining it and making the comparison. Those are the two things that people ask. Your purge can get stuck, and if it does, again, there's no buoyancy changes. Nothing that happens on the system makes a buoyancy change. So, and that's why we're doing through the class. And anybody that will come and try it, they'll go through the same experience.
One of the thing it reminded me, like, all of those drills were a bit rebreathers. So I dive rebreathers a lot, and rebreathers. One of the thing is when something fails, most of the time you have time to think about the failure. It's not an immediate quick response compared to obesity, which if you fully inflate yourself within a few seconds, you become extremely positive and you become very, very, like, having a rapid ascent, which generally doesn't end up well. But that's what I experienced actually when we did those failure, where that we had time to actually respond to the failure and then do everything correctly.
Oh, a lot of time.
Yeah.
In some cases, an hour. Yes, you will finish the dive before you will. Yes. And in many cases, as you saw, because they're so long before you even need to touch the battery or to run it, and as you know, sometimes you question yourself whether you actually need to. Your response time, it's a very forgiving system. It's actually the opposite of CCR diving in terms of how forgiving it is to failure modes.
Talking about technical diving, we talk about this a little bit.
All right.
Do you have any interest into bringing this to outside of the recreational world, more into the technical world?
Yeah, well, it applies itself because now you know that you can carry more gas with less weight, and because those are high pressure tank, then you have that advantage as well. Obviously, there's advantages in anything that has to do multiple tanks, be it side mount, back mount, or others. So as long as it's open circuits, there's advantages that are obvious to anybody who takes the class and immediately start to think about how they do that. What's less obvious is that it does have some application even in closed circuits. I don't want to get into it now, but there are things in the works. I think it's going to be a combination of both. In some instances, we are going to go beyond recreational diving. And I do trust the technical diving community because I know them, that no matter what we will do, they will do it better. It's just, there's a lot of ingenuity in the industry. I don't want to take it away from them. There are people smarter than me and more mechanically capable. And I have no doubt that people will do things that are more in the technical. We focus on the recreational market, and it's not even fair to say that. We focus on the single back mount tank because, as you've seen, the efficiency is increasing. You can elongate the dive time, and it's the main market. The technical diving community never really waited for anybody to tell them what to do.
That's correct. Okay, if someone wants to get trained, where should they go?
Anti-gravity.
Anti-gravity, okay, obviously.
Anti-gravity here. We are all over the world now. Florida, you have a lot of dive shops, all the way from the Keys and up the coast. From the Keys to the Tampa area. We have multiple dive shops in the mainland US and many more coming online. California, we're now expanding to the east. We have the Caribbeans, and we have Australia. So it depends where you are and what you want to dive. And as you saw from this event, soon here it's going to be in all kinds of liveaboards and destinations. So it depends. It's all on our website. What's not on our website is the developing ones. But I think now you know, I would highly encourage people to go and take the basic training so they can go and travel light and rent it on site because the systems are the same.
Great. Well, thank you very much for your time, Aviad. It's a pleasure. It's a pleasure diving with you as well and testing this. And yeah, I can't wait to see what you're going to do and meet you maybe somewhere else to go.
Absolutely.
But yeah, thank you so much.
You're welcome.
Okay. And I hope that you really enjoyed this episode. And if it's the case, please consider subscribing to the channel and then following on Instagram and have fun. Okay. Cheers. Bye, guys.